So yeah, it's a bit of a journey and some tools and some shift to the whole thing at the end. So it's like a real drama. But it's also something that went all over a couple of years. So first, naturally, the usual slide about who we are. I think most of you know Bayer. We are special in a way that we still have three parts to the company: crop science, pharma, and consumer health. And then we have the thing underneath that's enabling functions, which includes everything from HR to central IT. I am in central IT, so I'm not in one of the businesses. What we do is we provide services to everyone globally. And at Bayer, we have still about 100,000 people working, getting less now, but we'll see. And it's fairly nicely spread over the whole world. And when I, as an IT person, look at all these people, well, there is a lot of data that are produced. So this nice marketing slide, when I look at all the dots, I see data silos. And that was the state of things a couple of years back. And I think it's the same for a lot of other large companies and also for a lot of smaller companies. So around 2017, really going into full swing in 2018, there was an initiative to digitize Bayer, to make more of the many data sources that Bayer has. We called it Data as an Asset program. So it's exactly doing what it says: make data an asset and utilize it. Open it up for use. So you all know the old adage, how to eat an elephant, because with that many data so many data silos in the company, you have a lot of stuff to cover if you want to make everything known to everyone. So, well, the answer is byte for byte, right? So we said, let's take the most important use cases and then go through them one by one. First, look at, for that use case, which data do we need? Then see that you unlock them. So free them from the application where the data live. That can be a data lake, could be having an API where you can access it. So that's technical stuff. We won't talk about that about today. That would be another 2 hours or 3 or 4 or 2 days to talk about. The other thing is to actually make sure that the data sources that you need get fully understood, so that somebody who doesn't know the data knows where they're coming from, what you can do with them, what you're allowed to do with them, what's in there, what would I have as an advantage if I use the data. We call that the data knowledge base. At least we did at the time. This is a fairly old slide that I just reused. Then all this should lead to more fairness of the data, and we wanted to publish that information in a data marketplace so that everybody would know what we have, and then naturally make them available to do all the nice data analytics, what was the original purpose, to make the data more fair in the first place. And when you go through the use cases, after a certain time, we thought you would have gone through the most important data sets, and that would give us a big advantage when we need to reuse the data the next time. Again, we talk about that data knowledge base part. So how did we envision how that should work? There is physical data, that's for sure. And then there is business questions, like, can we predict how much we need of product X at a given time? How can we avoid that we need to scrap things because it took too long somewhere in the whole production process? Why does certain things occur? So data science stuff. So the idea was, let's describe things in knowledge graphs. Let's start with basic concepts. What is a customer? What do we know about a customer? What's a product? What do we know about the product? What do we know about production of that product? All the different steps. Have that in multiple layers, start with an enterprise core ontology, go down to a pharma ontology, go down to an MAPV ontology, so on and so forth, and then also have a layer of description to describe the actual physical data. And when you go through the semantic stack, you will find that once you create a schema, a description graph of physical data that is a relational database, you can even virtualize these data very easily. You can even automatically create APIs. There's a lot of advantage. So then you can go from a business question to the concepts like how can we avoid to scrap things, go to what is actually the production steps, where do we have how much time, where does it go wrong maybe, and then go from there to the finer grained details. So there's the packaging machine, there's stuff that we need to produce for that so that everything's available on time, so on and so forth, and down to the actual data. That was the idea. Now, to get all this organized, we would need something where we register all those graphs and provide the glue, right? The linkage between the graphs. So that knowledge graph itself should be in the same technology that these knowledge graphs are. Otherwise, it doesn't make too much sense. So why were we so keen on getting this done with semantic technologies? Well, you all know FAIR, right? Don't read that. You know that. Look at me. So we want the catalog to be fully fair. When we do all the work, we put all those thousands of hours into the information about data, we want them to be as open and reusable as possible. We don't want a vendor lock-in. We never know where we will be going technology-wise, so that this information should be as fair as possible. What we expect from the information that we register is at least that anything we have in the catalog has an identifier assigned so that we are sure what we talk about when we talk about something, and that we get enough metadata so that we have a nice description of it. Now, FAIR itself, as you all know, is not a prescription for an implementation. FAIR is just concepts. Now, when you want a technology stack, then you don't need to look far. There is the linked data principles. Some nice thing also started by Tim Berners-Lee, and that says use URIs as names of things, make them HTTP so that you can actually look them up. So an identifier is not some cryptic thing anymore. You drop it into a browser, and there pops up the whole metadata that you know about that thing. And then provide useful links to more information. That is the base for the semantic web as we know it today. So that's why we want a catalog that follows URIs, RDF, Sparkle query, taxonomies and ontologies using standard language, RDFS, OWL, and so on. Unfortunately, when we asked all the vendors, the usual suspects on cataloging, whether they would follow any of these principles, they say, oh, no. We have a relational database, we have our own format, its APIs available, so you can get your data in and out. But at that time, for us, it was so important so that we said, no, then we built our own catalog. That's what we did. It was maybe crazy, but it worked. And so we have two major personas. One is the people who have data and want to register them, so they need to have some way to get data in. And then you register first, give things an ID. So that catalog is the main giver of worldwide unique everlasting IDs. And then you have a description or the metadata, a contact person, which is more important than you may ever think about, so that you can actually go and write an email to someone or chat to someone who's responsible for something. And then naturally the metadata depend on the actual thing you want to register. A machine learning model has a different set of metadata than, let's say, a study or a normal data set. So that can be all changed, and everything's just controlled by an ontology. And then you want to have links. So for instance, to a data set, you get a link to a web page where there is a better description because the department has some ideas about their data and they have put that up into a nice intranet page. Or you get an API. Or for a knowledge graph, we have hundreds of knowledge graphs in there, and there you can actually download, in many cases, you can download the turtle file and just use it. So many things like that. Then, most importantly, that thing should be searchable. So we have a nice search user interface, easy to use, can also be used by machine. So I will get back to machine use a bit later. And finally, I mentioned the resolving of identifiers. You drop that thing into a browser in the intranet, and there you get all the metadata, or these endpoints that are linked, they have their own identifier. So you can get directly, using that ID, you can directly go to the API endpoint and so on. Now, the catalog itself is totally fair, but even if you enter any resources in there, they only get findable. They don't automatically, by registering them, they're just findable. But you will see if there is more to that, if they are also accessible, interoperable, reusable, or how far that goes. So that's all we needed from that catalog. The other thing we found out very quickly afterwards, that things have relations. So people are not just interested in the thing itself. A data set may be a subset of another data set, and that is maintained in some application. You want to know about that, because if something goes wrong with the data set, you then can follow down to where it's coming from and then go to the person who's responsible for that. Same as sometimes we have different subsets of data that together make the complete information. We train machine learning models with data, which is also interesting because that's all about, right? You need to know what you use to train a model, so that can be all followed up. We describe data sets with ontologies. Ontologies use and include other ontologies. They use taxonomies. Taxonomies are issued maybe on a yearly basis, or they get issued and they stay valid in different versions. So we also have version links so that you can follow through what is the latest version. You will always find what's the latest version, what's an older one, which one was actually used. Again, everything's included in the software. I talked about content. So we definitely have some content that's entered manually. So you just say, I want to register something. You get an empty sheet with all the metadata that you just fill out, and you can just save it, continue later, or you publish it. So then it's visible to everyone immediately. But more than 90% of the data in the catalog is not entered manually. It would be too much. So we can register data if there is an application that can actively work with an API. That's what we use. So from crop science, we get a couple hundred data sets updated 5-6 times a day by using the API. And then finally, we have something built. We call it the squirrel because it goes out, finds stuff, and puts it back into the nest. And so that thing can go and crawl information outside of Bayer even. So we have internal clinical trial databases, which are fairly inaccessible, but people want to know what studies are available. And then there are the published trials on clinicaltrials.gov. So we make that connection, and we have both entries. And then there is machine learning model repositories. We have other catalogs internally. And then we have a registration of applications, like 6,000 or 8,000 live applications at use in Bayer. So as I mentioned, we want to link data to the applications. Why enter the application separately? So we do it with the agent. Right, so with time, we also worked agile from start. So I'm used to work agile for more than 15 years, so we immediately used that way. So with time, we also improved the whole thing. Don't want to go into too much detail here. So we check if contact persons are actually still valid persons in the company. We check for technical endpoints. Are they actually accessible, or is that also garbage? Then you can set review cycles on the manually maintained stuff so that you can see as a user, oh, this is nicely maintained, and is it still within the cycle? You can have quick reviews over all your data as a data provider. Software provides notifications to those who are responsible, sends emails out to those who are too lazy to look into the software. So all that has been added with time. One thing that also turned out very useful is you can batch export information into Excel, do search and replace, and re-import it. So just imagine you have 500 ontologies and taxonomies, and you change the software where you host them, then you need to change all the endpoints to that, and that can be quickly done in a couple of minutes of actual work using that feature. Then there is what I call content usability helpers. So we built a full UI to maintain these relations. You can draw data maps with that and place them as you like them, put an identifier on that map and send that off to someone so they can call up the same map. And then you double click on any of these nodes, and then you get all the information that we have in the catalog about that stuff. And then you can subscribe, like to any modern system. You can get notified if anything changes in any of the resources. You can even save a search. The system searches for you on a regular basis. And if anything is new or different in that search, then you get a notification. And there's more stuff. Again, I don't want to go into any of those details anymore. One point, very important, we didn't think we would make any money with that. So we said we can as well publish it. So Collid is open source for a couple of years already. And since you have seen the logo, and I want to say Collid is not just saying corporate linked data. There's also a bird family, Collidae, Collids in plain speak, called mouse birds, and they are cool-looking birds, so we made the logo following that, just that you know. I mean, it's always important to know the nitty-gritty details. So we published it on GitHub a couple years ago. You can just search for Bayer Collid software, and as you can see, that was a search I did just 2 weeks ago, and you get 14 million entries, but the first hit and the third hit is actually our repository. The second hit is a nice paper from Spectroscopy Europe from a good friend of mine, Tony Davis, who's a professor in Wales, and he wrote about Collid, and I will come back to that in a minute. So, with all these years, now 5.5-ish years, what did we learn? First thing is, Collid is great to support semantic data. It's a great issuer of identifiers, making sure your identifiers are really unique and can be resolved. You can use the triple store. We have one use case where people actually use direct Sparkle queries on our triple store database. It's great to include external data. Normal data catalogs don't care so much about external data, but in pharma, in anywhere, basically in R&D, 99% of the information is outside of your company. And not everybody has the time to look up that information externally. So that's good. It's a great catalog of catalogs. So if you have other catalogs, this is the tool to put all the information in so that you have one place to search. It's easy to use, it's very versatile in its interfacing, it's very efficient search, so we don't get any complaints about that. It's very cost efficient, which is important. So 2 years ago, we spent more than $1 million on it every year. We are now down to not even a third of that. And that's full of full end-to-end support team, even being able to do some further development when there is not too much to do on the support side. It is extremely versatile and generic. So if you think about, yeah, but it's a data catalog. No, you can register anything because you can register things with metadata. So Tony, in his Spectroscopy Europe article, Finding Data in Today's Information, it's a couple years older, but he made the point of it could be registering chemical entities and projects, link them up with experiments, and then link to the actual scientific data that you measured for that. And that can be also automated, because if you put data in an ELN, you can as well put data through an API into a catalog. And then you have a searchable thing to find everything. Okay, so the other side. Graphs require special knowledge. So when you go to people like outside of R&D, knowledge graphs are not something they do. What they want is, they want an overview of where are their SAP data. What physical things do they have? How many millions of columns and tables do they have in SAP? How do they relate? How data flow through these big relational databases? Data lineage. They want to have data quality tools. So is there anything abnormal in the data flow? Formalized workflows. So there is 4 eyes principles on everything, right? You change a term, you need 4 eyes principles. That's not something we wanted. Collet was built to be a grassroots tool for everyone to register their data and make it findable for everyone. So commercial catalogs are actually the answer for that. So pre-made connectors are available. There is an SAP connector and everything. There are lineage harvesters in commercial tools. So in the end, we ended up with more than just Collet. So we now have Collibra as a global data catalog. So I'm actually the owner of both Collet and the operations of the Collibra system, which is used globally. Then we also have the Google catalog and Microsoft Purview, just because it's so nicely integrated with their web offerings. And it's very cheap to use in that case. There's massive back and forth interfacing between Collet and Collibra. There's some between the Google catalog and Collibra, but not too much. And Purview is basically running at the side. So the outcome of the whole thing is, FAIR is nice. But if you have data which are really yours and yours only, you won't share them ever with anyone, fairish is fair enough. If a vendor like Collibra tells you, yeah, we make data fair, it's not true. If you read through the actual FAIR requirements, it's not true. But it's fair enough, right? So within that world, that works. It's closed systems. It's very hard to put a taxonomy that you get from the internet as is into a system like Collibra. In Collet, we just put the graph into our triple store database. We refer to it as a metadata field, and off we go using that as a classification field that you can just use as a pick list. In Collibra, you need to recreate the whole structure of the taxonomy so that it can be used. So that's the difference. But again, it doesn't matter if you only work with this kind of data. So we still use both systems, and there are some things we only do in Collibra, some things we only do in Collet, because both have their own advantages and disadvantages. But now that the price of maintaining Collet is down so much, there's so many use cases still available for that. So with that, I'm at the end of this part.
Wow. Rolf, I think there is a huge amount of learnings in there for me, actually, seeing it all together. But over to you guys for questions. Any questions? I'm going to run over to you.
Okay, thanks for your presentation. Again, really amazing. As you see this trend in pharma for externalization of R&D and going with CROs and going just out, do you then need to internalize these this data again, or are you able to still work with that CRO data or that external capability?
Yeah, in case of Bayer, they tend to leave the externals alone to a large degree nowadays. So we don't see a lot of integration, but a tool like Collid is optimal for that because we use standards. We could just have the mapping between those and these things just by using another ontology, a mapping ontology, and that's it, right? So it would be perfect to do just that. But we don't do it yet.
Yeah, okay, but it's possible.
Yeah.
Any other? There's another one over there. This one.
Maybe I can do it without a microphone. So, Eddie from Roche, can you share a little bit what is the business value of having this data accessible? So it means you're an enabler, it's great, right? Everyone looking for this. But sometimes our management looking, what is now accelerating? What is better? Maybe you can share a little bit.
Yeah, it's always difficult to put some money tag on this. When we started out, we made the argument, we have hundreds of data scientists. They cost a lot of money, right? And they spend, on average, half of their time on finding data, getting a copy of the data, and then finding out if they are able to use them. That in itself, if you can just shorten that by half, because they know where the data are, they get an idea of what's in there, that saves already a lot of capacity for real things that they should do. I've researched a bit of what's available there, and honestly, all the business cases for data cataloging as a whole go in that area. Like, you save time, you get time because the quality of the data is better visible, you know where you need to search for the reason if data go bad somewhere. And it's mostly saving of time and effort. And then you also put time and effort in to get that thing working in the first place, right? So I believe that this only works if you make cataloging a real integration part of what you do on a day-to-day basis, so that the extra effort is minimal, but your whole data structure runs more smoothly. And then you can see over the years whether you actually get faster. But then also, it will be difficult to pinpoint that to your data cataloging because you now know where your stuff is. I don't have a better answer, unfortunately, because I didn't find any. I asked around in business. Same thing. Yeah, you know, there are a couple articles here, a couple articles there. It's something that higher management must want. And they need to push it, because you cannot force anyone who doesn't want to do it. You get a lot of arguments like, yeah, honestly, it worked before, right? Why should I change? Difficult.
Is it worth 300K?
It is certainly worth 300K. But it's not just 300K.
Well, I'm basing it on you're saying right now it's about $1/3 of a million that it costs to run it in
Yeah, it definitely is worth that, because we could not do the semantic stuff without it, without the identifiers. You know, all the identifiers of all the knowledge graphs that we create in-house are based on that system. And that's where we register. We have hundreds of knowledge graphs registered, so they are all based on these identifiers. I didn't even talk about the nitty-gritty details, so that we can actually resolve to a class, not just to the graph, because we have rules inside where we know identifiers that we don't really know. And stuff like that, that helps, yeah. Yes.
Can you do the other mic, please?
Well, I do it without mic.
Shout. Yep.
It's on. Okay. Oh, oops.
It's on.
It's actually more a comment to the previous round, because that's actually one of the critical questions. What is the measurable, tangible business value of this type of investment? You make a broad-scale investment into quality of data, have a metric, findability, fair data principle, but how does it pay off in business? So a customer of ours said, search today is not a single-step process. I do one, I do the next, I do the third, fourth, fifth. So I want to get to something down that I can grab and it's tangible for the human brain. So if I have not invested into that, I lose at each step of the search. So let's say 50%, I'm at 4, and at step 5, I'm sure to be wrong. So how often do you want our data scientists be wrong? That was the business value proposition. Have you heard that before? Does that make sense?
I did not hear that. Our data scientists just complained about the long time it takes to get to the right thing first, right? They did not even mention the many times they were wrong. But it's a vicious cycle. They get to a data set after a couple days getting access finally, and then they find out, oh, this cannot be used for my problem. So that's why this intermediate layer, so that you categorize your data correctly to a business problem, that's why it's so important. Yeah. It's all down to time and effort for the people who are really expensive, I think.
Good. Thank you, Rolf. Fantastic. Round of applause, please.